Okay, let's see a specific example of a molecule that has displays these ideas of stereoisomerism. And we're going to draw a molecule. It is going to be bromo, chloro, fluoro, methane. Okay, so it's a methane, very simple structure. And on this methane, we're going to have a bromine, a chlorine, and a fluorine. So let's draw this as an sp3 hybridized carbon. And all I've really done is drawn the skeleton of a tetrahedral carbon. Now let's sprinkle our 4 groups on this molecule. Here's a bromine, there's a chlorine, there's a fluorine, and last but not least, we put in the hydrogen. So this is our molecule. Now, as it turns out, there are 2 different ways that we could have drawn this. I mean, there's a lot of different ways, but there are 2 ways that we could actually draw this so we get 2 distinct molecules. And to highlight some of the ideas, I'm going to put a mirror plane. This is meant to represent a mirror plane. So if this molecule were to look in the mirror at itself, what would it see? It would see another tetrahedral center. The bromine would be in front of the page. The hydrogen would be again back, but the fluorine would be closer on this side, closer to the mirror, and the chlorine would be way far away from the mirror. Now, as it turns out, if you take these 2 structures and you try to, they are indeed mirror images. We drew them as mirror images. If you took these 2 structures and tried to superimpose them, make them occupy the same space. So what if we took both structures and slid them in towards this mirror plane and tried to make them completely overlap? Well, if we did this with these as drawn, the bromines would both overlap just fine. The hydrogens would overlap and take up the same space just fine. But the fluorines and chlorines would be swapped because the fluorine would move over and end up overlapping with this chlorine. Same thing, this fluorine would overlap with that chlorine. They wouldn't match. They would not superimpose. They would be non-superimposable. As it turns out, when people say things are non-superimposable, what they really mean is they are not the same. So if you want to tell if molecules are the same or not, try to superimpose them. If you can't make them superimpose, they are not the same, i.e. they are not superimposable. As it turns out, mirror images that are not superimposable are a type of stereoisomer. So you've seen isomers that you define as isomers because the molecules have a different bonding. The carbons are connected differently, but these are stereoisomers. They differ in terms of their 3-dimensional bonding. It's a special type of isomer. And in fact, mirror images that are non-superimposable are not just any old stereoisomer. Specifically, they are called enantiomers. So these 2 structures, one on the left and the right, these are different molecules, but they both have the same name. And so this becomes, first of all, it becomes a nomenclature problem. How do we identify which one of these we're supposed to draw because they are different? And then we need different ways to describe these molecules because we're going to encounter these, and stereochemistry is going to be an important trait that we're going to track as we see reactions and see the effect of reactions on stereochemistry. So we need to be able to recognize stereochemistry, and we need to be able to talk about it and communicate with each other to distinguish how molecules are changing during reactions. So in the next video, we'll look at the nomenclature implications of stereochemistry.